Hello everyone, welcome to the module 6 that is on logarithmic functions. The first lesson is on logarithms and logarithmic functions. Let's look at the learning objectives. We will have to learn to write logarithmic expressions in exponential form and to write exponential expressions in logarithmic form and to graph and analyze logarithmic functions. And the keywords are logarithm, logarithmic function. So what is this logarithmic functions? You can see, okay, before we go here, if you really want to know logarithm as a definition, it is basically the inverse of exponential function. We studied exponential in module 5. It's the inverse of that. But what exactly is this? Why was this done? I think so this came about maybe in the 15th, 16th century. I'm not sure, maybe 300, 400 years ago. It's a recent topic itself. I mean, no, there are many centuries, 3 to 4 centuries ago. But the thing is, this made many things easy in the sense, now, let me write something. 3 to the power 3. 3 power 2 is 9, 27. Answer is 27, isn't it? Now, I can rewrite this as 3 would be equal to log 3 of 27. So now this both are equal. Now we can try it in calculator as well. Log base 3, let me just log base 3, 27. Answer is 3. Now what will this help you? Now this is a simple problem, isn't it? Now what if it's a very complicated number? Say you need to find what power of okay, the problems must be well written, but now anyways, just for simplicity's sake, now what power 2 to the power x, what power of x is 32? How would you find at what exactly you should raise power 2 to get 32? Now in such cases, log will come very handy because we know if we take this to the other side, it's going to be log base 232. This means is equal to x. Now if you solve this, you will get this answer. What do you get? This means you need to raise the base, that is 2, to a certain number to get 32. That is the x value. So now let's just put this log base 2 of 32. Now you will get the answer as 5. But you might know 2 to the power 5 is 32 as well. This is a simple problem. But complicated problems, difficult problems may arise, and log will be very much handy to solve these sort of situations. And if it's a huge things, it can be easily, powers and all can be easily computed in this. Mainly, when it was found out, it helped the computation or solving methods and everything, but it made it a bit easier. And okay, let's see what exactly this is over here. We know exponential functions, which we did in the last module. 2 to the power x, base is 2 and x is the variable. This is exponential. Now you take random x values less than 0, more than 0, and you'll find the y, isn't it? Now same thing over here, we have interchange, inverse. What does inverse mean? Wherever x is there becomes y, y becomes x, in the sense, now y over here becomes x, x becomes y. All these x values are put in the y column, see, and y values become in the x. So this is it, this is interchanging. Now this is logarithmic graph, this is exponential graph. This is basically the inverse of exponential. So this is the 45-degree line which always demarks the inverse functions. So over here, imagine, let's take a point 0 and 1, right? This is 0 and 1 point. Here it's 0 and 1. Here it will be 1 and 0. You can see 1 and 0. These are the 2 points. Now other points, say for example 1 and 2. 1 will be 2 over here. Over here it will be 2, 1. 1, 2, 1. It's just inversed all together. So this is how we get this particular graph of log graph. Now if you're thorough with exponential, this must be pretty easy because it's just the inverse of it. Now then, we will, okay, now over here, this is the writing. I will show you in terms of a problem. It'll be much easier. Over here, you can see this. Log base 2 of 8 equals y. This can be changed to exponential function. How? Whatever is the base, right? You know, base of exponential function is something like this, and then you will have x. Now log base is over here. You should move it to the other side of equal to, and this becomes exponential. Now log is gone because you're taking exponential, in the sense 8 remains over here. Okay, 8 doesn't change. This log 2 is there, right? This 2 moves to here instead of y. This pushes this y upside, so y goes to the power. Now this is what is equal to 8. Now what's the answer? It is 3. Y to the power 2 to the power 3 is equal to 8. That is how we can solve it. Okay, but in your calculator you can solve both of these instantly, so that is easier. So now over here, before we solve the problem, it's very easy problems, but let's see. Whatever is the base of the log, you need to move it over here. And what happens when you move it over there? This goes upside to the power, and log cancels out. You're remaining with 64 as it is, equals to 4 power 3. Isn't this correct? 4 power 2 is 16, 4 power 3 is 64. Yes. So this is in terms of exponential. Now you're not solving anything, you're just writing in terms of exponential form. That's the only thing. This is it. This base goes over here, and this whatever is there equal to moves up, and that will be your exponential form, 4 to the power 3. Please try this by yourselves, and then we will do the answers together. Now here the base, always the log base is log whatever is given at the bottom, subscript down. Okay, superscript means power. This goes to the other side and log cancels out, right? This goes to the other side and becomes the base. So it'll be 3 to the power this whatever was over here. Don't forget the sign, take the sign also up. That will be equal to 243. Now if you're thinking, is it true? You can try it in your calculator. 3 to the power minus 5. Okay, sorry, 3 power minus 5, that is equal to 1 by 243. Yes, absolutely. And that's the answer. Here we have another simple one. You can pause the video anytime and solve the problems by yourselves, and then start it again. Here this goes to the other side. It'll be 9 power half, that is square root 9, that is equal to 3. Yes. So this is how we solve for exponential form. Very easy. The method you must remember. Now we need to, again over here there are some check problems. Please pause it and do it by yourselves. Whatever is the base moves to the other side. This goes up to the power. So it will be 125 to the power 1/3 equals 5. Now remember, 1/3 means it's cube root. Yes, cube root. Now that is a cube root of 125 is 3. A cube root of 125 is 5. That's the answer. So all you need to write is 5 equals 125 to the power 1 by 3. That's it. Now then, we just now did from log form to exponential. Now from exponential to log form, we are just doing the inverse of it, opposite thing. Let me write over here. Log base x equals y was there, right? Now all what you did, the base goes to the other side, x will remain. It was b to the power y. Now bring it back. This base, I need to bring it back over here to the other side. That time x will remain like that only, but base comes down and you must add log over here. See, this comes back, log base, and whatever was up comes down to y. This comes down, this goes over here. Opposite arrows. This goes over here, this will come down. So it will be 6 over your left side, and here you will have log base 7117649. That would be the answer. Okay, over here log 7117, that is equal to 6. Now you can double check this. Sorry. Here, log 7 117,649 will be equal to 6. That is the answer. Same thing over here. You can pause the video now and try it by yourselves. Here, all you need to do is whatever is the power comes down and this goes to the other side. So minus 3 comes down and log 8 base 8 1 by 512. This is the answer. I hope this is clear. Okay. Now then, what else? Over here, there's another same problem. 8 goes to the other side, power comes down, it will be 2 by thirds, and you will have log this base 8 4. This is it. Very straightforward problems. Please solve extra problems by yourselves and you will understand better. Pause the video now, try it by yourselves. I will do the arrows. 2 goes to the other side and becomes the base of log. This power comes down. So always write what is power down. This other side log 2 and write 512. You can double check by putting in calculator and that will be the answers. So you can write it either ways. 9 equals log base 2 512 or log base 2 512 equals 9. And also you can put some brackets over here. That's also fine. I mean over here only for 512. So that is also fine. Now then, we are supposed to evaluate these log functions. Now I have used the calculator. Obviously you can use the calculator directly. Now if you use the calculator, it's just one step procedure. Press this, type it out, 216 base, and this is 6. Your answer is 1/3. Other way, how do you do it? Now if you don't have your calculator, how to solve it? Get it into exponential form. What is this? By the definition of logarithm, you can take this to the other side and this goes to the power. Now you have 216 to the power y. Now why don't we get the bases same? We have done this in the previous exponential lessons, in the previous videos. So what do? Get the bases equal. How do you do that if you cannot guess this is 6 to the power? Now you know already there is 6. So you can do one way is 6 to the power 1. Okay, 6 to the power 2, 6 to the power 3, and you will get the answer. Otherwise you can do one thing, 216. You can take the cube root. Now I have not pressed that, so I can do this. So 1 divided by 2. This is square root, sorry. Now cube root means this one. Okay, that is 6. So we can write 6 to the power 3. If you're getting confused with this, because in the last videos I had done like this, cube root 216 is equal to 6. So 6 to the power 3 is the base. Here, now what do? Multiply 3 and y, the exponent. So you will have 3y and equals to 1. Remember, whenever the bases are same, you can equate the exponent. 1 equals 3y. Y will be equal to divide both the sides by 3. You will get 1/3. So that is the answer. Y is equal to 1/3. Now, you can directly put in calculator and also check it. How about a real world problem? The air pressure outside of an aircraft can be determined by the equation P equals B of 10 to the power minus 9h by 100, where B is the air pressure at sea level and h is the altitude in miles. If the air pressure at sea level is 14.7, now which is the air pressure? B value is given 14.7 pounds per square inch. Write an equation to find the height of an aircraft with when the air pressure is known. So basically what they're asking is, this is given, you need to, P is not given, it's fine. You need to write H equals to everything else. That's it. Now how do you solve it up? Let's see. We know the B value, right? Let's write B value 14.7. Now how can you get in terms of, how can you find the B? Instead of long difficult methods by taking the cube root or something like that, it's very simple by log. Take this. First of all, you need to only have this because this has a base, right? This has a base. So you don't want this number. You can't multiply this over here. So take it to the other side. Divide both the sides by 14.7. You're gonna get this. Now all you do is this, take it to the other side, and it will be log of base 10, and whatever is the power comes down. We have done this just now. Log 10 p by 14.7 equals minus 9h by 100. Now take the 100 to the other side and then divide both the sides by negative 9. You will get the answer. Taking 100 over here to the other side and divided by minus 9. They have done this together. You're just multiplying by 100 and divided by minus 9. So this cancels. You're remaining with h over here, and same thing at the left side. So this is it, and this is how we can rearrange any equation. This is all written. We will try this one over here. Pause the video, try it by yourself, and then I will do it along with you. I hope you at least tried. Now, the distance in miles that a tornado travels is y equals 10 to the power w minus 65 by 93, where w represents the speed of the wind in miles per hour. Write an equation to find the wind speed when the distance traveled is known. So wind speed is w, right? They want you to write w equals to all the other things. Okay, what do you do? Over here, since there is no coefficient multiplied, just take this to the other side. It will be log 10 y equals w minus 65 by 93. This is coming down. The power comes down. Now take this to the other side. 93, it will be 93 log base 10 y, and minus 65 becomes plus 65 equals w. Okay, w equals 93 log base 10 y plus 65. Now they have told use the equation to estimate the speed of wind to the nearest per hour if tornado is traveling 50 miles. Now y is what? The miles, right? They have given y as 50 miles. What is the wind speed? All you need to do is in the calculator 93 multiplied by log 10 of y, that is 50 miles plus 65. What is the answer? 223 miles per hour. That's the answer. Now remember, see this log base 10, and there is a log option over here directly, right? I'm using this because to specify the base, but let's remove this and put this. Sorry. Let's remove that and put this. This log is in default adjusted to the base 10. Okay, this automatically has base 10. If it is always base 10 problems, you can directly use this log. You will get the answer. Now then, graphing logarithmic functions. Now we have just told a while ago it's about inverse. Logarithm is inverse of exponential. Rather than this, we'll go to Desmos and just check it out over here. Now this is a log function. Can you see over here? But this is an exponential function, right? Now I've taken 10 to the power x as exponential. Why? Because log base is always 10. These both are the exact inverse. Now if you see over here 0 and 1, there will be 1 and 0. Okay, and now since it's 10 over here, we know at 1 it will be 10 over here. See at 1 almost, okay, 1 and 10. So what happens over here? It will be 10 and 1. 10 and 1. So that's it. You can easily find it out. Now over here this is 2. Whereas 2 will be 1. Okay, 2, 1. So same way you can find it out. There are so many relationships in this log function. I will not go in detail, but you try this. Go to Desmos, just type these equations. You can see these equations, right? Type it out. You can type your own equations and figure it out. Play around the different numbers, and you can produce new beautiful graphs, and you can understand the relationships between them. Now here we will stop this. We will try and see what about log base 2. It's a normal log function. Now if you write this in exponential form, what happens? This goes to the other side. It will be 2 to the power y equals x. Okay, this is fine. Over here you can see this thins. Why this changes shape? Because over here it is about 2 to the power. This was 10 to the power. Now this is basically the exponential function. Now if I add, say, y equals 2 to the power x, You can see it widens up, right? That's why this is wide. You can see it's exactly correlating. But that is not what we want to look. We want to look less than 1 and greater than 0, obviously. Look over here. What happens when you have 0.5? It flips out. When you have less than 1 over here. Now, same way you can try with minus sign. What happens when minus is there? It again flips out. So there are various things, you can check it out. Now, if it is less than 1, it already flips, and then you have minus, what happens? It goes up. So you can try figuring out various, relationships, and then you can easily graph it up. But now, before that, before we leave, over here, you need to know this basic thing. Okay, there will be 1 and 0. Now, if I add, say 2, what happened? Let me write this over here. This was, where was that? Over here. 1 and 0. You can see the graph jumped by over here 2 units. It's instead of 1, 2, 0, 3, 0. It will become, 1 and 0. Sorry, 1 and 0. It's not 3, 0. I'm sorry. It will be 1, 3. Can you see this? Okay, again. I am getting confused. I'm so sorry for this. Over here it was 1, 0, right? All you need to do is whatever is there plus to the y, because whenever you add something, this is to the y. 1 will remain. This will be 2. Okay, I don't know why I was telling 3, because in my mind I thought I pressed 3, I guess. So it should be 1, 2. You can see over here 1, 2 is there. Why? Because I did plus 3, the plus 2. If I had done plus 3 over here, it would have jumped more high. Okay, it will be 1, 3. I hope you're getting this. See, 1, 3. Now, what if I do minus? It'll just shift down. Okay. Now, if you go closely, okay, now it's much better. I was very, I should have zoomed in a while ago. That would have helped a lot. Now, here it is 1, 0. You can see over here it will be 1 and minus 3. Why? Because it's minus 3. Okay. What if I change the x value? It seems like exponential. If you have minus 2, minus 3 over here, x minus 3 equals 0. What is x value? It moves 3 units to the right. See, look closely here. 1, 2, 3, 4. Why? You need to add 3 units. It is 4, 0. Same way, if I add 3, it will be moving to the left side. Instead of 1, minus 3, it will be minus 2 over here. These are few of the changes. And it is similar to the exponential function which we have already seen. Now then we will see some problems on graphing. And these are the basic things. You can pause and go through them. It is very basic things over here. Where is the intercept? How is it moving? End functions and all that. Now, okay, this is what we had done. H is a horizontal translation. Now, if you have, say, 3, x minus 3, it will move 1, 2, 3 to the right. The graph moves right. Whereas if you have k, that is vertical translation, it will move up or down. So these are the translations. And this value over here, if it is positive, it is something like this, right? If it's negative, it goes downwards. So these are the basic things. Now here, log base 6x. Normal graph, no problem at all. Base is 6. You can do all this, but otherwise, how do you easily graph? I will just show you over here. Let me just take this over here. Let me just change this to 6. Okay, I need to write this. Okay, 6 now. You need to remember 1 and 0 will be the same. Okay, anytime this will never change. Where it changes is 6 will become 1. See, because the base is 6, right? Whereas 6 over here, this will be 1. 6 and 1. Can you see that? That is the thing. So what happens is whenever you have this one over here, you need to look, where is this? That'll be 0, 1 only. Next one, 6 and 1. That will give the graph away. So this is the thing they are doing. Because base is 6, it will be 6, 1. X will be 6 and 1. So these are the 2 points. And you can do it by writing, or you can directly find it out. And now look whether it's positive or negative. It's positive, so it will be this format. That's it. And now since it's greater than 1 the base, it will be from down to up. You can try this. Now looking at this, you should know the graph will be something like this. Okay, let's see the final graph. It's something like that. Okay, now how would you see the graphs? It's same. Now this 1 by 0.5 means 1 by 2. It is similar to the base of 2. You can see, let me take this off, let me put this over here, let me just make it proper. You can see the 0.2 and everything, they are just the same but inverted. You can see over here it was 2 1, but here it will be minus 1 2 only. X is 2, but it will be minus 1. Now at 4 it is how much? 2 4 2, but it will be over here minus 2. That is the only thing in the values signs. So this is basically like base 4, but just that it's inverted. So you will have 1/4 1 and then 4 1 and so on. You can get it. Okay, this is just inverted. It's just like base 4 but inverted. Now there's one more way. You can just take out your calculator and put some values. This is base 4 1/4, right? Write it, and instead of x, put some values. Say 1. At x equals 1, it should be 0. Yes, obviously it will be the same thing. Now let us take at x is equal to 4. What is it? Minus 1. 1 2 3 4, it will be minus 1. Now if you see 1/4 over here, 1 divided by 4, it will always be 1 when the bases are same, and this is same, it will always be the same thing. Okay, not only for this, let's change it. Say 3/4, and this is also 3/4. It'll be the same thing. Why? Because in terms of exponential, see, this is, let me take log 2 equals x. Now when you change it to exponential, this base goes to the other side, right? It becomes 2 to the power x. So how much times 2 to the power x equals 2? It's only 1, right? Every time it must be any numbers. When these both are same, it can be only 1, because only when you raise the base to that power 1, you will get the same answer. So that is why it is always 1 when this base and this numbers are same. So this is how we can graph. Various methods to graph, whichever is easy, you can easily follow it. Now here, transformation. What happened? Plus 3, that means it's moved to minus 3. This will be 1 2 3. It will be at 1, isn't it? 1 0. It has moved by 3 units. And what happened over here? Minus 1. So instead of this point, see, this should have been up, right? It moved 1 down, and 1 2 3. So this point, wherever 0 1, it moves from here and here. Then you can see the graph is like this. That's it. So from here you can see it will just be 1. Then you get the asymptote. So that's how. Always the transformations are very easy. Otherwise you can just put any x value, random x value in your calculator and check whether the values are true or false. And this is the method, like table method, but over here they're not using table, they're just using x and y value. If you're getting too much confused, you can just use the table method as well. It is also fine. Now then, over here they have given us few things. They have given you the graph already, g of x. This is given. No, sorry. Consider g of x, x minus 2, and j of x is shown. This is shown, okay, in the question. We need to graph g of x. Now look at this. This is a simple graph. Log, it will be like this, but since it's minus 2, it will go towards right side. See, this is 2, 4, 6, 8, 10. The graph must 0, 1, 0, 1 must be over here. But since it's minus 2, it moves by 2 units, 1 and 2. So this is the graph. It shifted. That's the only thing. And then we need to compare these both graphs. What you can compare is end behavior. What is happening? See what happens when x tends to positive infinity. It is going where? It is going towards infinity. So for this g of x, as x. Uh, Now, as x is going towards 2 plus, let me, okay, more than 2, that's what they are meaning, more than 2. Okay, 1 second. Sorry, there is one important thing which you must remember. This as x goes towards infinity, yes, g of x, you can see the function is going towards infinity. That's fine. But what is this 2 plus? This is one important thing. Over here, since it's minus 2, x is equal to 2, isn't it? The value of this log cannot be less than 2. That is why it's plus. That means it's only from 2 positive side, just right of this, because it goes down, it's an asymptote, it will not touch 2, it will be right of 2. This is very important to know. So as x is just right of 2, what is happening? This function is going towards minus infinity. You can see over here, this graph will be just right of 0. It will never go 0 minus. Why? It cannot go there. It does not exist there. Now you can see that this graph, as it is just right of 0, it is going towards positive infinity. Whereas as x tends to infinity, it will go towards minus infinity. It won't go straight. It will keep on changing little by little. It will be changing little by little. But as you go to infinity, it keeps on increasing towards a big number. That is the differences. Now here we have been told to translate. So no, sorry. Okay, you need to tell what is this is the question. This graph is the question. Okay, sorry, I have not done the animation properly. They have given this graph as the question, and they have told you if log base 4x is there, it will be something like this, right? What is the difference between these two graphs? This is our parent function is log base 4x, but what is the addition of k, that is the horizontal vertical translation? Just count 1, 2, 3, 4, 5. It has been that 0,1 point has been moved to 5 units up. So you need to just add 5. That's it. If it was moved towards horizontal direction, plus or minus, then it would have been in bracket, okay, with the x. That's it. Now here you need to write what is the vertical translation. You can see the vertical translation is 1, 2, 3, 4. So plus 4. Here they have, you can see it's minus, just minus, okay. Why? Because it's going to the opposite direction. But look, 0,1 is at same point. Only when 0,1 this point moves, then there is translation. Here only the negative sign. That's it. Okay, and that is the end of this lesson. It is similar to the first lesson, exponential, but it's just inverse of that. And you might find it hard at once. What you can do is you can try solving more and more problems. Go on Desmos, try to understand the graph, the different relationships of graph. Now I couldn't go through all the different things, what happens when you change many things. So you need to spend time by yourself and do it, because whenever you change one single thing, you see there's a pattern. There are various patterns. Try to find the patterns, and then you will find graphing is very easy. So graphs, some students might find it a little bit difficult, but if you spend more time, if you understand how it moves, just by looking at it, you can easily tell which graph is which. Not only for log or exponential, for anything like quadratic, cubic, and everything. So do spend time on Desmos, understand the relationships of graphs, what is the pattern, and then it'll be very easy. Thank you for watching the video. Stay tuned for the next video, which will be coming up shortly. Bye-bye for now.